The topic we're going to look at today is the topic of factoring. We want to begin by looking at some basic factoring problems involving simple basic situations such as like the first one we're going to look at is 4x plus 28. Now, if you look at this problem itself, you'll notice that 4x plus 28 is mainly a situation where what you'll be looking for any type of factoring problem that you do. You're always going to be looking for something called the greatest common factor. If you're looking for the greatest common factor itself, what you need to look for is a number that will both go into both 4 and 28, the largest number possible. So in this case here, the largest number possible that will work is actually the number 4. So we take that and put that on the outside, so we say to ourselves, okay, 4 times what gives you 4x? That will definitely be just plain x itself. And then we go do the same thing. 4 times what gives you 28? That will be the number 7. And then you've got your answer right there like that. Now if we take another example, do the same basic thing for something like this. You've got 12x plus 15y minus 21z. Now in this case here, we're looking at the numbers 12, 15, and 21. The greatest common factor for those three numbers turns out to be the number 3. So in this case here, we'll put the 3 on the outside like this, and then we'll go 3 times what gives you 12x. That turns out to be 4x. So put the 4x right there. Plus 3 times what gives you 15y. That turns out to be the number 5y is what we have right here. We go minus, so 3 times what gives you 21z, that would be 7 because 3 times 7 is 21, and put the z right there. So you've got, again, 3, 4x, 5y, minus 7z. Okay, let's take a look at another example. Same basic thing, same basic idea. So we'll go with 36x plus 54y. Now in this case here, the greatest common factor for the numbers 36 and 54 turns out to be actually, we can try numbers like 2, we can try 4, we can try other numbers like that, but again, those are not always going to be the ones that we'll want to work with. The greatest common factor for 36 and 54 turns out to be the number 18. So come over here, put the 18 down here like this. 18 times what gives you 36? That'd be 2, because 18 times 2 is 36, and got a z over here. Plus 18 times what gives you 54y? That would be 3y right there. So we've got 18, 2z plus 3y, because that will give you the resulting answers over here. Now we can try some things with some variables instead. So if we take something like cx plus cy, the greatest common factor for this one turns out to be the letter C because it's common to both terms. So we put that on the common term thing on the outside, and we go C times what gives you CX. Turns out to be just plain X itself. Do the same thing here. C times what gives you CY. That will be Y is what we come up with. Now we could become more adventurous and say something like this. If you take, let's say, a triangle with a circle plus a triangle with a square. Now the common symbol in both of these terms turns out to be the triangle itself. So in this case we're going to go with the triangle on the outside, and we're going to come up with triangle with a circle plus triangle with a square. That will be this thing over here. Okay, so again, basically if you look at all these examples we've done so far, the thing which we need to look for and have is the greatest common factor, is the number which will go into both terms, the greatest possible number, or the variable that's common to both terms, or the symbol that's common to both terms. Now, not every single problem that we look at is going to involve just numbers or symbols or letters. In this case here, let's take a look at another example. Let's suppose you've got some variables instead. Suppose you've got the variables x, and you've got the other variable x squared. Now in this case here, what you're looking at is you're looking for the greatest common factor for both variables. The common factor for both variables turns out to be the one with the smallest exponent. So in this case here, the one with the smallest exponent will be just plain x itself. So that goes on the outside. So x times what gives you x? That would be 1 plus x times what gives you x squared, that will be x itself. Because remember, when you multiply variables together, what you want to keep in mind is that you'll be adding exponents instead. So let's take another example. Let's suppose you've got x squared plus x to the third plus x to the fourth. Okay, in this case here, what you've got is you're looking for the one with the smallest exponent. That turns out to be x squared itself. So we take out the x squared, that goes on the outside, and we go x squared times what gives you x squared. That would be 1 because that will give you that right there, plus x squared times what gives you x to the third. That turns out to be just plain x itself because, again, 2 plus 1 is 3. Do the same thing over here. X squared times what gives you x to the fourth. That will turn out to be, actually, it's going to turn out to be x to the second. Now, if we take a look at some more different types of problems, suppose you've got some numbers and variables together. Suppose you've got 18x to the fourth plus 42x to the third. So in this case here, the simplest thing to do is to look at the numbers first, 18 and 42. The greatest common factor for 18 and 32 is the number 6. So that will go on the outside right there. Okay, now the next thing we need to do is we look for the variables. We've got x to the fourth and x to the third. So once again, as we said before, we always take the one out with the smallest exponent, which turns out to be x to the third. So now we go 6 times what gives you 18? As we already know, that will be the number 3. X to the third times what gives you x to the fourth? That will be x to the first. Plus, do the same thing here. 6 times what gives you 42? That will be the number 7. 7 times 6 is 42. Now the next thing is you got x to the third times what gives you x to the third. Actually, there's nothing. It'll be just plain 1 itself. So you get a situation like that. We close it up with parentheses. Now to do the same thing, let's do another example of something like this. Suppose you've got 11x to the fourth plus 22x to the third minus 33x to the, let's say, 7. Okay, so there's our terms right there. Now, if we take a look at this here, first thing we do is look at the numbers, 11, 22, 33. Greatest common factor for those three terms turns out to be the number 11. Now, we got x to the fourth, x to the third, x to the seventh. The one with the smallest exponent turns out to be x to the third. That goes on the outside. So now, 11 times what gives you 11? That turns out to be 1. X to the third times what gives you x to the fourth? That will be actually x to the first. Plus 11 times what gives you 22? That will be 2. X to the third times what gives you x to the third? 1. So if you say that in that case there with already a coefficient there, we just leave it as it is and move on down to the next one. Now the next thing we need to do is we want to say to ourselves 11 times what gives you 33? It turns out to be negative 3. So now x to the third times what gives you x to the 7? It turns out to be x to the fourth. And there's our answer right there. Now, taking a look at another example, same exact thing. Let's suppose you got a couple variables instead of just plain old one variable instead. Let's suppose you got x to the third, y to the second, plus x to the 7, y to the first. So in this case here, first thing we do is we've got a 3 over here and a 2. Now we look at those two and we also look at these 7 and 1 over here. We've got, for the variable x, we've got x to the third and x to the 7. We take out the one with the smallest exponent, which is definitely going to be x to the third. Now we look at the y squared and the y to the first, take out the one with the smallest exponent, which is going to be y to the first. Now we've got to go work our way backwards. So we say to ourselves, x to the third times what gives you x to the third? That will be 1. Okay, y to the first times what gives you y to the second? It turns out to be y to the first, because y times y is y squared. Plus, now we go x to the third times what gives you x to the 7? That would be x to the fourth. And then we've got y to the first times what gives you y to the first? It would be just plain 1 itself, so you just put a parenthesis right there and that's done. Okay, let's finish up with one last example on this one here. Let's try an example of something like, let's suppose you've got, let's say 4x to the fourth, y to the second, minus 8x to the third, y to the 7. So in this case here, if we look at this example, we're looking at 4 and 8. The greatest common factor for 4 and 8 actually turns out to be the number 4. So that goes right there like that. Now we look at the x to the fourth and x to the third. Take out the one with the smallest exponent, which will be x to the third. Now we got y squared and y to the 7. Take out the one with the smallest exponent, which is y to the second. Now we got to work our way backwards. So we say to ourselves, 4 times what gives you 4? That will definitely be 1. Then we've got x to the third times what gives you x to the fourth. That will be just plain x itself. The next step we got to do is we say to ourselves, okay, y squared times what is y squared? 1. So there's no need for anything right there. Now we got the minus sign here. 4 times what gives you 8? That will be 2. Then we go x to the third times x times x. Okay, so we got x to the third times what gives you x to the third? It'd be 1. Then we go y to the second times what gives you y to the 7. That will be y to the fifth. And there is our answer right there. So once again, the major concept about these factoring problems, all of them, is you're trying to find the greatest common factor. The greatest common factor, whether it be in terms of the numbers that you're looking at, or the symbols, or the variables itself. But again, remember, if you're working with the variables, you've got to take out the one with the smallest exponent. That's the greatest common factor for a variable. Thank you so much.